Okay, great. Let's get going. First off, let's go over the final again. I know you're going to get annoyed with me going over this so many times, but it's so. Yeah, I don't mind doing that, Jimmy. Give me just 1 second. It's so we don't so someone doesn't say, "Oh, I didn't realize that." December 4th is our final. You've got to get the final done. That's a Friday, December 4th. You have to get it done that day. It'll open up on that day. If you cannot get it done that Friday, you need to get with me as soon as possible beforehand. And I do not mind making. Actually, I will make accommodations. It's not that I just don't mind. I will. Okay. So get with me ASAP and get that done as soon as you can. If you need to make accommodations for the final.
You said December 4th, right? I'm sorry.
Yeah, it's Friday, December 4th. Yep.
And when did you say you were going to open it?
That day. It'll just open up. You can make it any time that day. That's fine.
Okay.
Okay. Genesis, let's see here. 23 through 29. Let's see. This is on page 466, Jenna. Yeah. Okay. So let's do like, let me do 23. So 23 says we've got log base 2 of 64. And the question states, evaluate each of these without using the calculator. So remember, your goal is to get 64 into a base 2, which you can. I might have to take the calculator out, but 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times another 2 is 64. So it turns out 64 is 2 to the 6th power. Okay? And because of that, these cancel, and it leaves you with 6. It was that rule that said if these match, then whatever is left in the exponent leaves you with 6. But to begin with, and your springboard is to think, can I get this number, whatever it is in here, into a base, whatever this base is? So base 2. Okay? 25 log base 5 of 1/5. I thought we did one just like this. Log base 5 of 1/5. 5's in the denominator. We have to bring it to the numerator. So to do that, you've got to raise it to the -1 power, right? And any number raised to the -1 power puts it in the denominator. So again, now these cancel, and it leaves you with -1. Let's see if the next one. 27 is a lot like that. It kind of combines both of them. Actually, yeah, let's do 27. So 27 says, well, what about log base 2 of 1/8? Well, it's in the denominator, so now I'm going to use a negative. But before I get there, I'm going to make this 8 into a base 2. 8 is 2 times 2 times 2, so it's 2 cubed. Then I'm going to bring it up to the numerator. Okay? So once I have 8 into a base 2, 2 cubed, then I move it to the numerator by making it negative. And so it leaves me with -3. And then 29 is log base 7 of the square root of 7. Well, the square root of 7 is 7 to the 1/2. You have to think of radicals as exponents. And remember, if you have something that's the square root, it's really just some number raised to a power. It's a number raised to a fraction. And whatever the root is your denominator. So the square root would be 1/2. Like the cube root's going to be 1/3. The fourth root's going to be 1/4. Okay. Hopefully that helps. I know, look, guys, I know these are not the easiest sections at all. Like, I kind of expect questions as we go along. Okay. Any other questions from 4.2?
Is this stuff going to be on the final?
Oh, yeah. So this is the next test, and then it'll be on the final. Yeah, definitely.
Okay.
Okay, let's start on 4.3 then. So 4.3 is really just more properties of logarithms. It could be, written as 4.2b, honestly. But 4.3 is it's just called properties of logarithms. But we've already gone over the basic properties. Now there's just more properties of logarithms. So I'm going to say properties of logs. Okay, properties of logarithms. And there's some basic properties that we can use to expand a logarithm out. And what we'll do is we'll expand and simplify because of it. But they're based on exponential rules because these are kind of like inverse exponential rules. Let's look at the first property. It's called the product rule. The product rule says, look, if you've got a logarithm, I don't know why I made that capital. It isn't not usually capital, but if you have some logarithm, doesn't matter what the base is. If you have multiplication inside, you can separate this out. You can separate it out with addition. So log base b of m plus log base b of n. Okay? So if there's multiplication inside the logarithm, you can separate it with addition of logarithms on the outside. This actually comes from the fact that it's an exponent. And remember, whenever you multiplied the same bases, you added the exponents together. That's really where it's coming from. We don't have to know that. We just have to know that if there's multiplication on the inside, it's addition on the outside. So if we looked at an example of this, if we had something like log base 2 of xy, just something goofy like this, just to show the rule. Well, the question would state expand and simplify. Expand and simplify. So we're going to expand this by using this rule. And we've got multiplication on the inside, x times y. So it's going to be log base 2 of x plus log base 2 of y, right? Now we can't simplify this any further. Log base 2 of x and log base 2 of y don't simplify. I'll do one of those here in the next example, okay? But that's the basic rule. So if we wanted to look at one that was really the same question, but now we're actually going to get some simplification. Let's say log of 10z, okay? Log of 10z. Well, again, this is being multiplied, right? It's 10 times z because the 10 is a coefficient of the z. So when you expand it, it's going to be log of 10 plus log z, right? Now remember, if the log's by itself, it's a base 10. So I'm going to write that right here. And the rule, that basic rule said, look, if these matched, this whole thing just went to 1. So it's 1 plus log of z, okay? So this would be expanded and simplified. Expanded and simplified, okay? Questions, comments, concerns? There's a few more rules, but I can sit right there for a second and answer anything if you need me to. Just one second. Okay, so let's go to the second rule. So that's the product rule. The second rule is called the quotient rule. The quotient rule. And it says, look, if I've got some log base b and we're dividing on the inside, let's say m over n, you know, if multiplying became addition, kind of makes sense that division becomes subtraction. But it's top minus bottom. So log base b of m minus log base b of n. So it's always the top minus the bottom. Okay, top minus the bottom. So let me think of an example. Okay, let me do one with the ln. So let's say we had ln of e squared over y. Ln of e squared over y. So again, expand and simplify, okay? Expand and simplify. So the rule to expand this says, well, okay, we've got division inside, so therefore it becomes subtraction. So it's going to be the top, ln of e squared, minus the bottom, ln of y. Okay, that's the quotient rule. And then we've got to think, okay, can we simplify one of these? Now, the ln of y, we can't simplify. The variables inside, that's not going to work out. Ln e squared, we can. Remember, the ln and the e A good way to think of ln and e is that they're opposites of each other, so they can cancel out. And remember, ln is just log base e. So this is like saying log base e of e squared. So the e's cancel, the log and the e cancels, and it leaves you with 2 minus ln1. Okay? 2 minus ln1. Kind of cool. Okay? So I'm going to give you one to try. Let's say we have log base 2 of 16 over x. So I want you to try this. I'll give you a second or a minute to try it. Log base 2 of 16 over x. So expand and simplify. Expand and simplify. I'll give you just a minute. I mean, just get started and see if we can get through it. Okay. So log base 2 of 16 minus log base 2 of x, right? But log base 2 of 16, that's a lot like one of those that Jenna asked me about at the beginning. We need to see if we can get 16 into a base 2. Yeah, and we can. 2 times 2 is 4, times 2 is 8, times 2 is 16. So this would be log base 2 of 2 to the 4th power minus log base 2 of x. These cancel again, it leaves you with 4 minus log base 2 of x. Okay. Questions, guys, before I introduce the last, really, I guess, kind of the last simplifying rule. Yeah, we'll get to solving in 4.4, but the last rule for actually simplifying these things. Any questions, comments, concerns? Okay, so let's look at the last rule, which is the power rule. And it's kind of similar to one of the basic rules, but the bases don't match. So the power rule says this. Not rule, power rule. Says if we have log base b of, let's say, m to the n power. So now we're raising the n inside a logarithm. Turns out you can bring the n to the front. So this becomes n times log base b of n. So a really kind of basic example would be, let's say we have log base 4 of 5 to the, I don't know, 3rd power. Log base 4 of 5 to the 3rd power. Well, you can bring that 3, you can bring that 3 out to the very front. So 3 log base 4 of 5. Okay? Pretty straightforward. So if we had, let's say log of x squared. Well, same thing. Because the x is being squared inside the logarithm, you can bring the 2 out front. So it's just 2 log x. Or if we had, say, ln the 4th root of x. Well, we could use this one because, remember, the radical is really an exponent, right? This is the same as saying ln x to the 1/4. I could bring the 1/4 out front and say this is 1/4 ln x. This is going to help us more with solving because it made, kind of a complex looking variable inside of it, the ln, just x, right? It makes it just a cleaner variable. that's the 3 rules. So I'm going to do some examples with these from the book, but do some examples where it combines 1 or 2 of them, or maybe all 3 of them. Yeah, okay. So this, I'm on page 472 if you're following along in the book. And I'm going to just steal some examples it gives us. This is on the bottom of page 472. It says, it kind of gives you the properties for expanding logarithms, and then, which is what we just talked about. And then some examples at the bottom. Example 4. So this is A for example 4. It says log base b of x squared times the square root of y. And it says use logarithmic properties to expand each expression as much as possible. So first off, I know there's some exponents going on in here, but before we hit the exponents, we have to deal with the multiplication. So we're going to expand the multiplication out first. Remember, if it's multiplied, it meant addition on the outside. So this would expand to log base b of x squared plus log base b. Now look, I'm going to write this square root as y to the 1/2. Just get in the habit of doing that. Whenever you see a radical, automatically write it as a fractional exponent. Okay. Now, look, there's no division going on, so I can use the property we just went over, which was the exponent rule, or the product rule. I can bring the 2 out front, so this becomes 2 log base b of x, and I can bring the 1/2 out front, 1/2 log base b of y. So we've expanded this completely, and we can't go any further. This doesn't simplify, okay? So we've expanded and simplified completely. Kind of cool. Okay, questions about that? Okay, I'm going to give you one, and I want you to try it. Now, this isn't B. This is, we'll just call it A2, okay? So I'm going to steal it from the book. Log base B of x to the 4th cube root of y. So this is a times. X to the 4th times the cube root of y. So try that one. I'll give you a second. Try expand and simplify. Okay. Let's see. So again, it's got multiplication. I have to deal with the multiplication first. So log base b of x to the 4th plus log base b. Now I'm going to write that as y to the 1/3. And then I've got to bring the exponent out front. Log 4 log base b of x plus 1/3 log base b of y. Okay, so any questions before we go on to one that kind of combines all 3 of them? This had 2 of them, right? The addition expansion and the exponent expansion, or the power rule. Okay. So let's look at their second example. It says this is their B. Log base 6 of the cube root of x over 36y to the 4th. Okay? So log base 6 of the cube root of x divided by 36y to the fourth power. Okay, so now there's a few ways to expand this actually, but I'm going to deal with the division first. Okay, I'm going to deal with the division first. So this would become log base 6, and I'm going to write this as an exponent again. So x to the 1/3 minus log base 6 of 36y to the 4th. Okay, so it was division, and I've got the top minus the bottom. They're pretty straightforward. And now I'm going to simplify. Now I've got two separate examples. I'm going to simplify each one. Okay, so this first term here, I can bring out the 1/3. And I get 1/3 log base 6 of x. Now the second one, notice I've got a multiplication here, right? It's 36y to the times y to the 4th. So I can expand that out. Now look, we've got to subtract everything in this term. So when we do that, we got to be careful. I'm going to put a parenthesis here. Actually, I'm going to put a little bracket. So minus log base 6 of 36 plus log base 6 of y to the 4th. Right? That would be this term expanded. Rewrite this here. Okay, and I'm going to leave the minus sign. I'm just going to leave the bracket. So I'm going to simplify what's inside here. Log base 6 of 36. Okay, now we have just numbers, which is nice. And we need to see, can we get 6 into a base 30, can we get 36 into a base 6? And we can, right? 6 times 6 is 36. So this becomes log base 6 of 6 squared, right? The second term, look, we can't simplify this, but we can bring the 4 out front. Okay? So we get 1/3. Now you don't have to write this over and over again. If you're working this, later, you can kind of scooch through it. So we get minus. This just turns into 2, right? And this one's simplified. Now we have to distribute the 2 to both terms in here. So we get 1/3 log base 6 of x minus 2 minus 4 log base 6 of y. Okay? Boom. Shakalaka. We did it. This one took a little longer. It doesn't have to take you this long, honestly. And I'll tell you what can make this go quicker, and it's kind of a trick, is if you've got, when you expand, I'll show you what it says. When you're expanding these out, if you're dealing with division, whatever's in the denominator is going to wind up with a minus. So this would be minus log base 6 of 36 minus log base 6 of y to the 4th. Okay, so you can kind of go about it quicker that way because we know that in the bottom we have minus signs. But either way is fine. In the end, this is one of those things where we might work these two separate ways and still get to the same answer because there's just a few different ways to get to the same conclusion. Okay? Nothing wrong with that. Okay, so I'm going to give you one I want you to try now. Let's say we've got log base 5, the square root of x over 25y cubed. So I want you to try this one. Expand this and simplify. I'll give you a few minutes. This one will take a little longer. Give you a few minutes to do that. do this. If you're going, keep on going. We'll get there. So it's going to be top minus bottom, right? So we got log base 5. I'm going to write this as x to the 1/2 minus log base 5 of 25 y cubed. Now, what I was saying is, like, when you expand this, you can make both of these negative in one step. So you could say, now look, I'm going to bring the 1/2 out front. So it's 1/2 log base 5 of x. And you could say minus log base 5 of 25 minus log base 5 of y cubed. And it's because this minus sign means you have to negate both of them. Okay, you're distributing that minus sign through. Okay, so unlike before where I did it at the very end, you can do it at the very beginning. Both are fine. There's nothing wrong with that. Now, look, 25 I can write as 5 squared. Look, I'm going to be a little lazy. This is just always another color. Okay, try out another pin here. See how this picks up on the screen. 25 is just 5 squared, right? So because of that, I can cancel the 5 and the 5 there in the logarithm. It's going to leave me with 2. So I get 1/2 log base 5 of x minus 2 for the second term. Minus, now I got to bring the 3 out front. Log base 5 of y. Okay, a lot less steps because I did the minus sign and I did the simplification kind of on the side there. Okay, any questions? Okay, so this is expanding, and we also have condensing, and it's where we go the opposite way. So if you know one, you can do the other. And I know what you're thinking. I don't understand the first way. How am I going to understand the second way? Well, I'll tell you, when you're working the homework, this is the second part of the homework. So I'm going to give you a few examples, and it's okay if you don't grasp these. It's okay if you need to go back and watch this later and then see it. But you really kind of have to understand how to go both ways to simplify these completely. So the first type of examples we just did were expanding. Now we're going to do condensing. So condensing. Now, condensing logarithms, we're going to have something like, I'm going to look at a very, very basic example in your book. Let's say like log of 250 plus log of 4. Okay? So as you can tell, this is expanded already. There's a plus sign, right? But we know that both of these have the same base. They're base 10. Oh, I can use that little marker. They're base 10 here. We're just not writing it, right? And because of the same base, and there's addition, that means we can condense them in with multiplication. So 250 times 4. Okay? So this is condensing. If we have addition of the same logarithm, we can condense it inside of multiplication. It's the opposite, right? If we can do it one way, we can do it the other way, kind of thing. Now, 250 times 4, that would be, I think, 1,000. Okay, now you can say, oh, 1,000, that's 10 cubed. This is just 3. But I'm going to be lazier and just put in my calculator. I've got base 10 in my calculator, right? That's just the log button, not the store button, but the log button. Put in a log of 1,000. I get back 3. And I'm done. Okay? But the main idea here is for condensing, you got to see your operation, it's addition. So that means I condense it inside if I have the same logarithm, same base. I can condense it into 1 with multiplication. Okay? With multiplication. Okay? So let's look at maybe a division one. Yeah. Now I'm doing a few from the homework. This is number 46. You try this one. Log base 3 of 405 minus log base 3 of 5. So try this one. Condense. Condense these together and then simplify. Condense together and then simplify.
Hey, Mr. Shirley.
What's up?
So hitting log just gives you the base log, right?
Base 10. So we won't be able to do this one in the calculator like that.
Oh, okay. That's what I was trying to do.
Yeah, you're not, and it's not going to come out the same. Oh, wait, not divided by 3, but divided by 100. Yeah, so we condense this one. It's 405 divided by 5, right? What is 405 divided by 5?
It's 81.
Perfect. Yeah, we'll get, actually, at the end of this lecture today, we'll go over how to put this in the calculator. It's just, it takes a little trick to do it. But 81 is a base 3. It's 3 to the 4th power. It's 3 times 3 times 3 times 3. So this winds up being log base 3 of 3 to the 4th power, because that's what 81 is. So we wind up with 4. We wind up with 4. Okay. Okay, let's do one with variables. These two, I think the ones with numbers are harder because you have to kind of come up with the answer in a way. A variable, we're not solving for anything here. We're either condensing or, simplifying, expanding and simplifying. It's not really about solving. So when you see a variable to start with, it kind of makes it a little easier. Like number 52 here. We've got 1/3 ln x plus ln y. Okay, now one of the rules about condensing that I forgot to go over, excuse me, is that you cannot have a coefficient out front. So see, we have this coefficient of 1/3. Now we know how to deal with it, but you cannot have a coefficient out front if you're going to combine them together. But this one will be with multiplication. So I've got to bring this 1/3 inside to the x. So ln of x to the 1/3 plus ln of y. And then now I can combine them together with the plus sign, which remember was multiplication. So ln of x to the 1/3 times y. And they're probably going to write this as a radical. I don't know why, but they just like that. So this cube root of x times y. Now that y is not inside the radical, right? The 1/3 only went to the x value. Okay. Let's see here. And that's good. You can get the rest by doing that. And I want to give you some that'll challenge you once you get there. So and maybe you haven't seen them yet, which is a good thing. It'll challenge you along the way. Okay, yeah. Now let's use the change of base formula. Okay, I'll write it over here. Change of base formula. Not as cool as the early 90s band, Ace of Base, but almost. They were from Iceland or somewhere, I don't remember. But they were a pop band. You've heard some of their songs because they were on like Pitch Perfect. But anyway, if you want to look up Ace of Base, not a horrible band. Catchy tunes. So the change of base formula we can use to get an actual number from your calculator. So like, and I'm going to steal one of these from the book. Like number 72 says log base 6 of 17. And the question says, in 71 through 78, use common logarithms or natural logarithms in a calculator to evaluate to 4 decimal places. So look, we don't know log base 6 of 17. We can't put it in the calculator unless you have a newer one. Some of the newer ones let you change the base. But we can use a nice little rule that says if you've got a logarithm and you want to find an estimate for the logarithm, you can use this. I use ln. You can use log 2, but I'm going to use ln. You take the ln of what's inside the logarithm, so 17, and you divide it by the ln of the base, ln of 6. So it's this is called the change of base rule. And what it does, so I'm going to take my calculator out. And I'm going to do ln of 17. Be careful and make sure to put parentheses. Divided by ln of 6 and I get 1 point, I think they wanted 4 decimal places, 1.5812. Okay, 1.5812. Okay, and I'm going to check this just to show you that it's pretty close. So if I wanted to check this, I could actually, now I'm going to box this in because I know it's the answer. But if I wanted to check it, I could use what I know about exponents and logarithms. So log base 6 of 17, I'm going to use these squiggle lines. That means approximately. Log base 6 of 17 is approximately 1.5812. I'm going to write this as an exponent. This means 6 raised to the 1.5812 should be really close to 17. Okay? Should be really close to 17. I'm going to check it. 6 raised to the 1.5812. Oh, yeah. 16.9985. That is pretty close to 17. Okay? So that's one way to check it, is bring in something we went over in the last class, which was moving logarithms to exponentials. Okay? Moving logarithms to exponentials. So now, just to make sure you get this, I'm going to give you another example. Let's do like 78 here. It says log base pi of 400. So try that. You have to use a calculator, right? This is a calculator thing. See if you can, now it says to round it to 4 decimal places, okay? See if you can get an approximation rounded to 4 decimal places. Pretty close approximation. Let's see. So it's going to be ln of 400 over ln of pi, right? I'm going to write down here. So that's approximately, so I'm going to do this. ln 400 divided by ln. Now to get pi, I think you have to hit second caret. I'll give you the pi button. Boom. 5.23, I guess it would be 40, right? If you round it to 4 decimal places, 2340, yeah. Now just to check it, it would be pi raised to that should give me about 400. So pi raised to 5.234. Yeah, that's pretty close to 400. 400.0206, something that's close enough. And so that's my answer. We're going to use that when it comes to solving. It's kind of nice to get an answer when we solve these things out. Okay. Any questions about that? Comments, concerns?
Okay, so when we just checked that, you needed to get 400. Yes, okay.
Did you get it?
Yes, I'm good.
Awesome. Now that's it. Now today's lecture is not that long, but I'll tell you, I can't go on to 4.4 before we finish 4.3. The stuff you've got to really understand the stuff in 4.2 and 3 before you go to 4.4. I will tell you, 4.4 has my favorite picture in this entire book, and it's on the bottom of page 479. If you have the book, it's a glorious picture of, yeah. Anyway, if you have the book, you can look at it. But for homework, we're gonna start. It starts on page 477. Actually, it's gonna end on page 477 too. 1 through 33, and then 41 through 61. And then I need you to hit 71. These are all going to be odd. 71 through 77. And these are good. Yeah, that's good. So make sure to do just the odds for these. Okay, just the odds. So page 477, 1 through 33, then 41 through 61, 71 through 77. all the odds. I'm going to stay on here for a little while. So if you guys have questions or anything like that, I'm